Greetings, everyone. Today we're going to explore domain and range of functions. Specifically, we're going to look at graphs. You don't need to jot this down, but remember that when we're finding the domain and range of just a set of numbers, we list the numbers in order with squiggly brackets and no repeats. So what we need to explore now is, what if I have a continuous graph? Not just abrupt points. That's what we're going to work on. Make sure that you have the notes sheet. If not, you can take notes on your own paper. You're just going to have to do a couple drawings. So first of all, let's talk about the domain and range from a graph. Sometimes it's not possible to just list the abrupt x and y values because the graph is continuous, meaning every decimal value on that curve is included, or maybe there's an arrow and it goes on forever. So to list the domain and range, we can't make a list of points, so instead we make a list of intervals for the values. Meaning we look at the graph and we read it and we say, in terms of x and y, how far left does it go and how far right? And then we look at the range or the y values and we say, look at the bottom, look to the top. So we're going to, I also like to think of this as maybe the boundaries in the sense. What's the lowest the graph exists? What's the highest? What's the furthest left and the furthest right? If you need to pause this video to jot these notes down, please do so. Now, the way that we talk about left to right and bottom to top is a little different than how we're going to write it. When we write it, we're going to use what's called interval notation. It's a notation that states the interval. Some important information. When we have an open dot for a boundary, we're going to use parentheses. Remember back to Algebra 1, when you would graph a less than on a number line, you used an open dot. So when we have that open dot, we're going to use parentheses. Brackets, when we have a closed dot, we are going to use a bracket. So a harsh box bracket is what I call them. That's what we want to use around our domain or our range. And what we're going to work on is if the line goes forever, if I have an arrow in a direction, that means it's considered to go to infinity. So we're going to have to practice writing our infinity symbol. All right, so in your notes, we have a bunch of images and graphs where we are going to find the domain and the range. So I like to look at it as how far left to how far right for domain. X is domain. So visually, I actually like to put, maybe if you're using pencils or papers or even your hands, to kind of show that left bound. Like, where can I stop on the left side of the graph? And where can I stop on the right side of the graph? So if I take a look, the furthest left that graph goes on the x-axis is 0. And the furthest right where that graph exists is 1, 2, 3, 4. And so I'm going to write my domain as 0 to 4. So we write the left number and the right number. It always goes least to greatest. And then we're choosing brackets because it's included, or it exists at 0 and at 4. There's no openings or gaps. Let's look at range. Now, range is considered bottom to top. So let's look at how low that graph goes to how high that graph goes. It goes as low as 0 on the y-axis now, and it goes as high as 4 on the y-axis. So 0 to 4, and I exist at those points. There's no gaps, there's no open circles, so my range is also 0 to 4. Let's look at the next graph. How far left? Well, I can't use this box method because look, there's an arrow. If I tried, it's going forever left. And then if I looked at the right side, there's an arrow. It's going forever right. I can't put a box there, which implies that I'm going to go from negative infinity to infinity. Always least to greatest. Yes, there's a negative infinity, and yes, there's a positive infinity. Think about it like the national debt, right? We're going negatively in the infinity direction. Let's take a look at range. How low to how high? Well, I have an arrow that's pointing down, which means it's going forever. And I have an arrow going up, which means it's going forever. So that means my range is also negative infinity to infinity. Let's take a look at the next two examples. If I'm talking about the domain of this graph, meaning left to right, if I try to put a boundary on the left, I can't. See how it's going forever left? And then if I move it to the right side, I can't. There's an arrow. It's going forever right, which means forever left, forever right is negative infinity to infinity. Let's take a look at the range. Range is bottom to top. Well, if I take a look, I have a definite bottom limit. And if I try to find the top limit, I don't have one because there's arrows going forever up. So let's talk about that. The lowest it goes on that y-axis, if I look at my box, is -2. And the highest it goes is forever. So we're going to go -2 to infinity. Now, the -2 gets a bracket because it exists at -2. Even though there's not a solid dot, there's not a gap, right? There's not a visual open circle. You'll also notice that all the infinities have parentheses. I can't exist exactly at infinity, so infinity is always parentheses. Let's take a look at the next one. How far left? Well, there's an arrow, so that doesn't work. And how far right? There's an arrow. So I have no limits. My domain is forever left, forever right. Let's talk about range, low to high. If I follow that arrow, it just keeps going down, 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 very slowly, but it does. The range, if I follow that arrow and try to create a block or a boundary, it doesn't work. So I'm also going forever down and forever up. All right, let's take a look at the last two examples. For the domain of this first graph, if I try to put a boundary or something to the left, I can't because there's an arrow. It's going forever left. If I look at the right, though, it ends. So if I put that line there, you'll take a look. It goes to 2 on the x-axis. So forever left and to 2 on the right. Now that 2 is going to have a bracket because there's no gaps or open circles. Let's look at the range. Range is always low to high. I do have a low point, right? It ends at that low point. How high, though? I can't. There's an arrow, and it's going to keep going up, up, up. So the lowest I exist is -2, and the highest I go is infinity. Now at -2, it's going to be a bracket because there's no gaps or openings. Let's look at the next one. How far left to how far right? Well, I'm going forever left. And I'm going forever right. There's arrows left and right. So -infinity to infinity. Let's go bottom to top, low to high. Well, I definitely have this lower boundary where I don't go any lower than that value. As for how high, I don't have a boundary because there's arrows. It's going forever up. So the lowest it goes on the y-axis is -4. The highest it goes on the y-axis is infinity. A bracket on -4 because there's no open circles or gaps. All right, so as always, make sure you check Google Classroom to see what your task is for this. Take a look at PowerSchool. What do we need to spend time catching up on? Let me know if you have questions or seek out Sabre Center help. And until next time, have a good one.